Hello, my name is Leen, and in this video I would like to talk about the AGT Peripheral found on one of Renesas' newest microcontrollers, the RA2L1. In fact, it's a standard peripheral found on all RA microcontrollers. In this block diagram, we can see the RA2L1 group, shown here on the right. The RA2L1 includes the ARM M23 CPU core with up to 48 MHz frequency. Operating for 1.6 to 5.5 volts, the RA2L1 is offered with flash sizes of 128 and 256 kilobytes. The RA2L1 includes many efficient and unique features. This video will focus on the AGT peripheral. As I already highlighted in one of my earlier videos, the RA2L1 is packed with features. In this video, I will detail box number 2, the innovative peripherals found on the RA series. In this case, the Asynchronous General Purpose Timer, or AGT for short. So what is the Asynchronous General Purpose Timer? It is extremely low power and provides functions beyond those available in the RTC, or real-time clock. For one thing, it does not need to rely on an active P clock, local oscillator, or subclock, but can operate asynchronously from an external trigger. It can also generate an interrupt to wake the system from standby. The AGT operates completely autonomously without CPU intervention after it's first configured. Here we see a functional block diagram of the AGT as depicted in the user manual. The AGT peripheral is found on all RA microcontrollers and consists of two 16-bit timers with unique features. Here you see a simplified block diagram of the AGT. The asynchronous general purpose timer is made up of two 16-bit timers that can generate configurable output pulses, measure the pulse width and period of an external signal, and count external events. The AGT can be operated in 5 different modes: timer, pulse output, event counter, pulse width measurement, and pulse period measurement, each of which provides flexibility and capability to perform a variety of counting functions. The AGT can be operated using a number of different clock sources, such as a peripheral clock, a low-speed on-chip oscillator, an external trigger, and AGT1 can be triggered by the underflow signal of AGT0. Renesas provides an example project bundle for all their RA evaluation boards. These demonstrate most, if not all, of the peripherals on the device. The AGT example project for the EK RA2L1 evaluation board is initiated with a software input, which in this case is a random key press in the RTT debug console. This starts channel 0 of the AGT in one-shot mode. Once channel 0 expires, channel 1 starts in a periodic mode and toggles a LED. Channel 1 expires once the user-specified timer period expires. Now I have configured an alternative AGT example program which demonstrates the event counting mode. In my opinion, the most useful mode. This mode is extremely useful in low power applications where the CPU is put into sleep mode and the AGT monitors external events. The AGT can toggle a pin after a set number of events, or in fact wake the CPU to undertake some action. In this example, I have connected a button to AGT0 that counts down from 2 and then triggers a pulse for AGT1 that in turn counts down from 3. When AGT1 reaches its underflow state, it toggles its output that I have connected to a LED, so in effect the LED toggles every 6 button presses. In a real-world application, this principle can be applied to motor control and equipment maintenance applications. For instance, to trigger a grease gun to lubricate a lathe after several hundred rotations. This timing diagram shows how the two AGT timers interoperate. Each time the button is pressed, the AGT timer is decremented. It goes to an underflow. When it underflows, it triggers AGT1. When AGT1 underflows, it toggles its output that is connected to a LED. This operation is totally automatic without CPU intervention. I will now demonstrate this project on the EK RA2L1 board. Now demonstrating the AGT timer example on the EK RA2L1 board. You see that I have added two jumper leads, one from the S1 switch to the input of the AGT 0 timer, and another from the output of the AGT 1 timer to the LED 3. Now if I press the switch 2 times, three times, 2 times, then it toggles the LED, and if I press it another 3 times, 2 times, so 6 times, the LED comes up again. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This concludes the demonstration. Download the AGT example and implement these features in your next application. The alternative AGT example is included in the downloads together with the presentation. In closing, I would like to thank you for your attention, and if you have any questions or recommendations for future videos, don't hesitate to contact me on this address. Thank you for your time.